In this video, we will again be looking at graphing a polar equation, and we'll go through a few more steps than just simply looking at the calculator like we did in previous videos, and we'll use some point plotting to get some points. First of all, we're looking at the equation r equals 2 plus 2 cosine theta. Think of that as r equals a plus a cosine theta, or maybe we wrote it as r equals a times 1 plus cosine theta. If you recognize those generic forms, we'll see that this is going to be a cardioid. And from here, part B, we want to find some polar coordinates. So let's use the point plotting method. We're just going to take in some thetas and plug them into the given equation. R equals 2 plus 2 times cosine of 0. We'll plug in theta of 0 first. That's going to be 2 plus 2 times the cosine of 0 is 1. So 2 plus 2 will give us 4. That means our coordinate in polar form is r, which is 4, theta, which is 0. So we have 1, 2, 3, 4 on the polar axis. Next, let's plug in the angle of pi thirds. R equals 2 plus 2 times cosine of pi thirds. That is 2 plus 2 times. Let's see, cosine of pi thirds is 1/2. So that is 2 plus 1, which is 3. That means the coordinate would then be r is 3, theta is pi thirds. So finding pi thirds on the grid, pi thirds would be this guy here, and we want to be at 3. 1, 2, 3 on that angle. Next, we want to also see what's happening at pi. R equals 2 plus 2 cosine of, let's plug in pi. We have 2 plus 2 times the cosine of pi is -1. So 2 plus -2 gives us 0. That means we're looking for the point 0 pi. R is 0, theta is pi. So that's going back to the origin, or the pole in this case, since we're talking about polar coordinates. For the intercepts, we can see that we have 4, 0, and 0 pi. To describe the symmetry, let's go to the calculator. And let's type in the equation. That is 2 plus 2 cosine theta. Looks like we have a cardioid that is symmetric about the polar axis. That means if this point is up here, we're going to have a point down here as well. And from here we can get a quick sketch of our cardioid. If we wanted more points, again, we could certainly get more points by plugging in some more values for theta, but with what we're dealing with, we've got enough. The symmetry, again, it's symmetric with respect to the polar axis, essentially the x-axis. As I mentioned in previous videos, we could certainly test algebraically to see what the symmetry is, but for what we need in this class, we're just going to visually inspect using the technology and see that we have symmetry about the polar axis. In this example, we have r equals 2 minus cosine theta. If we think about the generic equation, that would be r equals a minus b cosine theta. Notice a and b are different in this case, so it's not going to be a cardioid. And in this case, b is less than a, or a is greater than b. So if a is greater than b, we're looking at a limison. And this one will be without an inner loop. Without inner loop. Remember, if b is bigger than a, that's when we have the inner loop. Here, a is bigger than b, so no inner loop. And now to get the polar coordinates, let me just remind you of how we could do this in the calculator. I'm going to go to y equals and change that equation. First of all, r equals 2 minus cosine theta. So we can see what this looks like. I'm going to zoom 6 to standardize the window and maybe zoom in a little bit. Let's change the window to go again from -5 to +5. We'll do that in both x and y's. And then I want to square my grid, so zoom 5, we'll square the grid a little bit. And it looks almost like a circle, but there's a little indentation here, it's hard to see. So this is our limison. Now that we have this, let's plug in some values for theta to find the corresponding r values. Second trace, then we want value number 1. Theta, let's say, is 0, hit enter, and we get our value of 1. So we have 1, 0. R is 1, theta is 0. Second trace value, let's make theta pi halves. So second pi divided by 2. Here we get an r value of 2. So r is 2 when theta is pi halves. Second trace value, this time let's make theta pi. And we get 3. So r is 3 when theta is pi. Second trace value, this time let's make theta 3 pi divided by 2. This time we get 2. So r is 2 when theta is 3 pi halves. And finally, let's check 2 pi. When theta is 2 pi, we get a goof. I'm honestly not quite sure why it's complaining about that, so let's just try it by hand. That still works. R is equal to 2 minus cosine of 2 pi. Well, we know that 2 minus cosine of 2 pi is 1. 2 minus 1 is 1. So we get 1 comma 2 pi. So now let's plot all of those on the grid we have. We have 1, 0. We have 2 pi halves. 3 pi. 2 3 pi halves. And 1 2 pi. Then we'll just connect the dots. There's a little dip at this point, otherwise it should be a smooth curve. Again, we're just going for a very rough sketch. It looks like we again have symmetry with respect to the polar axis.